Okay, we've graphed using calculators, we've graphed using by hand methods. The problem with some of the by hand methods is you have to get from a large function like this to something you can use. Now, in the last video that we did, this was already factored down for you. Well, if this were already in its pieces, this would be no problem. We already know that the leading term test tells us positive, so it's going to be up. We know it's fourth power, so we know it's going to look something like that. And so we have some broad things, but we need some zeros. To get zeros on this, unfortunately, we're going to have to do some breaking it down using some longer methods. We're going to be using polynomial division, which is really nothing more than just long division. Now, for those of you that have been a while since you've done long division is 4, 3, 7, 2, and I want to divide that by 17, okay? Now, the question we always ask, say, how many times does 17 go into 4? Well, it doesn't. Well, how many times 17 go into 43? Well, it looks about like twice. So we say 2 times 17, 34. Big key here is then we subtract. When we subtract, we get 9. Next step is always bring down the next number. Say 17 goes into 97. We come up with, second quit, 97 divided by 17. That's going to go in 5 times here. Okay, now I kind of cheated just for time's sake, but you could kind of figure it out. We said 9. Well, it's not going to go in 9 times, not going to go into 8. It's about 20. That's about 100. So somewhere in the neighborhood of 5. So we come up with 5, put a 3 up here. We come up with 83. Then subtract. We come up with 14. Bring down the 2. Well, I'm going to see. Maybe it's an 8 somewhere here. I get 6. I get 5. I get 13. Looks pretty good. I come up with 6. So I have... Now, in grade school, we would simply say R6. However, as we move forward in math, we understand that that's really 6 out of 17, and we put it in fractional form. This is what I suggest because that's what we're going to use moving forward. Now, going through that long division process, there's a reason for it. Because we're going to use the exact same process here when we divide it by x plus 1. Let's see if x plus 1 is a factor of this guy. So we say x to the 4th minus 6x cubed plus x squared plus 24x minus 20. Does x plus 1 go into it? Well, same question. We said how many times 17 go into 43? Well, how many times does x go into x to the 4th? The answer, x cubed. So we say x cubed times x is x to the 4th. That's good. Now, if you give it away to one piece, however, you must give it away to both pieces. So you have plus x cubed. Now, over here, once we multiplied, we subtracted. We're going to do exactly the same thing here. When we subtract, though, we're going to have to make sure that we give the subtraction to both pieces. If this was already a subtraction, we would make it a positive. In either case, that goes away. We're left with negative 7x cubed. And just like last time we brought the 7 down, well, we're going to bring down the x squared. There's just a plus sign. So how do I turn x into negative 7x cubed? That's negative 7x squared. So we get negative 7x cubed minus 7x squared. Now I'm going to subtract, which means subtract of a negative is plus. Subtract of a negative is plus. Those go away, leaving 8x squared. Bring down the plus 24x. X goes into 8x squared. A positive 8x times, we get 8x squared plus 8x, because again we give it away to each piece. Then we have to switch the signs. Now, once we switch the signs, I come up with 16x, and I get a negative 20. Yes. And so I say plus 16 goes in, and you say 16x plus 16. Then I switch my signs, and in this case I come up with negative 36. There's no way I can turn x into negative 36, so we say that's our remainder. So we're going to say plus negative 36 over x plus 1, just like we said 6 over 17. This is not a factor. X plus 1 is not a factor here because it does not go in evenly. Does not go in evenly. You say, that is a whole lot of work. Yes, it is. So what we're going to do is we're going to use what's called the remainder theorem. The remainder theorem says if I take the original, x to the fourth minus 6x cubed plus x squared plus 24x minus 20, and I want to see if x plus 1 is a factor. Well, if I solve x plus 1, I say x equals negative 1. The remainder theorem says if I plug in negative 1 everywhere I see x and I get 0, then it's a solution. If I plug in f of negative 1 and it doesn't equal 0, it is not a solution. So let's see what we come up with. If I plug in negative 1 to the fourth minus 6 times negative 1 cubed plus negative 1 squared plus 24 times negative 1 minus 20. That's going to go away and become positive 1. This will stay negative, but negative times a negative is a plus 6. That's going to be a plus 1. This is going to be a negative 24 and a negative 20. That's negative 44 plus 8. Negative 44 plus 8 is negative 36. You'll notice I come up with the same remainder there as I do here. But you'll notice this was a lot quicker process. Good news is this is quicker. Bad news is if it did work, we don't know what it divides into. We would still have to go do this whole process. So maybe there's a way we can put the two things together. That's called synthetic division. Synthetic division takes all the coefficients. So instead of x to the fourth, I have 1, because it's 1x to the fourth. Then negative 6, then positive 1, then positive 24, then minus 20. I'm dealing only with the coefficients because we already know it's x's. We already know it goes from fourth to 0. And we now are going to use the negative 1 again. But watch the process. This is a little different. Unlike this, which ties into previous knowledge that you know, this is a bit more of a parlor trick. Now, we're bringing down the 1. You always just drop down whatever number is there. Now we're going to multiply these two. Gives us negative 1. Then I'm going to add. So when I add it down, I get negative 7. Well, again, negative 1, negative 7 is positive 7. Add it down, you get 8. Negative 1 times 8, you get negative 8. You get 16. You get negative 16, you get negative 36. Again, if this worked, just like you should have ended with a 0 here, just like you should have ended with a 0 here, in synthetic division, you should have ended with a 0 there. Since we don't end up with a 0 there, it is not a solution. But at least we know that since it went from x to the fourth, we've gone down a power, so we're 1x cubed minus 7x squared plus 8x plus 16 plus negative 36 over x plus 1. And that matches exactly what we got earlier. So we have long division, remainder theorem, synthetic division. All of these are necessary for breaking these things down. Okay, very quickly, let's go ahead and do one of these. By the way, if there were no x squared term, you would simply put a 0x squared in as a placeholder. You would do that in long division, synthetic, or otherwise. In this case, we could do long division. I'm not going to do that for time's sake. Let's do synthetic division. It's much, much quicker. I have 1, negative 6, 11, negative 6. I bring down a 1, so I get 1, I get negative 5, I get negative 5, I get 6, I get 6, and I get 0. Again, because I get 0, that means it is a solution. So, what was x cubed is now x squared, 5x plus 6. At this point, I can say x minus 1 times x squared minus 5x plus 6, and now I can break it down even further. I can try to factor this, which in this case I can, and so now I have all my various solutions. X equals 1, x equals 3, x equals 2, and I can graph them up. 1, 2, 3. It's cubic. It's going to look something like this, so we go up, down, up, and we're in good shape. Again, remainder theorem would have been if I had simply plugged in 1 everywhere I see x, so 1 cubed minus 6 times 1 squared plus 11 times 1 minus 6. And so I get 1 minus 6 plus 11 minus 6, all of it equals 0, just like we found. So, we have synthetic division, long division, and remainder theorem. Your homework for this section is going to be 331, 3 to 36, multiples 3. Alright, so that should do it for the week. Make sure you have these 3 sections made up, ready to go. Thank you.